Hello dear students, in this video we are going to talk about the natural base e. So let me give you some introduction about it. Exponential functions with e as a base have the same properties as the functions you have studied. The graph of f ex e to the power x is like the other graphs of exponential functions such as fx equals to 3x. We learned how to graph this. It was like this one. It was like this graph. So it means the graph of e to the power x and 3 to the power x are the same. They are alike. They have the same properties, as you see in the graph. The domain of fx equals to e to the power x is the set of all real numbers. So our domain is R, all real numbers. The range is y greater than 0. The function fx equals to e to the power x is the natural exponential functions. We call it like this. The first example, we have to graph exponential functions. We have to graph this one, but that one is easy. Let's graph the hard one in the exercises that we have. Let's graph the fourth one. To graph this one, we have to make a table. We have x and y. We give points of x like easy points. We have -2, -1, 0, and 1, 2. Those are easy points to graph our function. So when you put x into this function, if you put x here, we will get y. So let's do it by a calculator. For minus e, shift to len, e to the power -2. We start from -2 to the power -2 equals to 3.86, 3.9. If we put, do not erase it, just come back like that, put -1, we will get 3.6. 3.6. If you put 0, we will get 3. If you put 1, we will get 1.3. 1.3. If you put 2, we will get -3.9.4. -3.4. So we have to plug these points, these 5 points here, into this graph. Okay, let's do it. Here we have -2 with 3.9. -2 with 3.9. It's nearly here. We have -1 with 3.6. -1 with 3.6. It's nearly here. And we have 0 with 3. 0 with 3. And we have 1 with 1.3. 1 with 1.3. It's nearly here. And we have 2 with -3.4. 2 with -3.4. That's it. Now we have to graph it. The graph starts like that. It goes for down. So it is decay graph. Why? Because our e here, it is negative. So the graph is a decay graph. What about the domain and range? For a domain, we know that domain is related with the x-axis. So we see that our graph from -infinity, it goes to +infinity according to x-axis. So it means our graph is the set of all real numbers. It means our graph is R. What about the range? For range, we know that we are going to look at y-axis. As you see, the graph starts from 4, but it doesn't cut 4, so it means y, and it goes for negative parts. When it goes for negative parts, it means y is less than 4. Because if y is less than a number, it means it goes for negative parts. Or we can write it like this. 4, it doesn't include to negative infinity. That's it. This is how we graph the natural exponential function. What about 5? 5 is the same as 4, but instead of we have negative e, we have positive e, and our graph is 1 minus x. Let's solve this one as well. For exercise number 5, we have fx equals to e 1 minus to the power x. Now, we have points, we have the table, we have point negative 2, negative 1, 0, and 1 and 2. Just plug these points of x in here, we will get y. Let's use a calculator. We have e and 1 plus 2. Why 1 plus 2 for the first one? Because here, because if we have e1 minus negative 2, it will be e to the power 1 plus 2. Why? Because these two, when we multiply it, it will be positive. Minus multiplied by minus, negative multiplied by negative, it will be positive. So it will be 1 plus 2. 1 plus 2, it means 3. Or by a calculator, we can just do it. Immediately equals to 20. So the first one equals to 20. What about the second one, which is we have negative 1. Negative 1 as well, it will be plus 1. So it means e to the power 2 equals to 7 to the power 4. 7.4. 7.4. If you put 0, it will be e to the power 1. It means 2. It will be 1 minus 0, 2.7. 2.7. If you put 1 minus 1, it will be 0. So immediately equals to 1. E to the power 0 is 1. If you put 2, 1 minus 2 is negative 2. If you put 2 by positive, it will be 0.36 or 0.4. 0.4. Let's plug these points on the coordinate plane. We have negative 2 with 20. This point, we don't have 20. 20 is too much, so we don't need to do this one. We can skip this one. So move to the second one. We have negative 1, 7.4. We have negative 1 with 7.4, negative 1 with 7.4. If it is 7, so 7, nearly it will be here. And we have 0 with 2.7. 0 with 2.7. It's seen here. We have 1 and 1. 1 with 1. And we have 2 with 0.4. 2 with 0.4. So as you see, the graph, it goes like this. It will never cut 0. Okay, so we graph our function. So what about the domain? The domain will be R, the set of all real numbers, because according to x, it comes from negative infinity to positive infinity of x. And for range, y is greater than 0. Why? Because according to y-axis, we have 0, the graph, we have from 0 until positive infinity, but 0 is not included because it doesn't cut 0. So y is greater than 0, or we can say like this: 0 never include and goes to positive infinity. That's it. It's very easy. Let's solve some examples about natural base. A logarithm with a base of e is called natural logarithm and it is represented like ln. So if you have a log and our base is e, so it will be ln. And natural logarithms have the same properties as log base 10. So if you have a log base 10, it is the same as ln. Logarithms with other bases. It's a logarithmic function with base e. The natural logarithmic function fx equals to ln x is the inverse. Look at this important point. So ln x is the inverse of natural exponential function of fx equals to e to the power x. It means fx equals to ln x, the inverse is fx equals to e to the power x. The graph of fx equals to ln x is shown in the right figure. For example, we studied that this is the graph of e to the power x. And the graph of ln, which is the inverse of ex, e to the power x, this is the graph of ln x. That's it. So let's solve example 2, and we have some extra examples as well. For example, here we have ln e to the power negative 2t. So these two will cancel. Negative 2t is the remaining one. And here we have e to the power ln x minus 1. When e with ln with e, if they get each other, if they face each other, they will cancel each other. So these two will cancel, x minus 1 is remaining. In here, we cannot immediately cancel them because here we have 5. So this 5 goes up. This 5 goes to the previous place, which is ln x to the power 5, like this. So these two will cancel, x to the power 5 is remaining. Or check it out examples we have. So these two, they will cancel, 3.2 is remaining. We cannot cancel e with ln because we have 2 here. So when we move this 2 to the previous place, which is it's a power, it will be e ln x to the power 2. And then these two will cancel, x squared is remaining. For branch C, we have ln e to the power x plus 4y. Immediately, these two will cancel, x plus 4y is remaining. That's it. We have some extra examples about ln and e. To solve these examples, let me give you a hint. For example, if we have x to the power 2 equals to 9, how can you find the value of x? We can simply take a square root for both sides. So these two will cancel, and x equals to plus and minus 3. This is how we found the value of x. We take the inverse of square power, which is square root. Here, if we face these kind of problems, if we have e, how can we cancel e? We can cancel e by ln x, by ln. If you face these problems, these exercises, how can we solve them? First, we have to use their inverses. For example, the inverse of e is ln. So we can take ln for both sides. It will be ln e x minus 1 equals to ln 2. We will take ln like this. So ln with e, they will cancel. x minus 1 is remaining, and ln 2 equals to 0.7. And then we move this negative 1 to the other side. X equals to 1 plus 0.7, and x equals to 1.7. That's it. This is how we solve it. For the second one, if we have ln, we can cancel ln by taking e. So how can we take e? We take e as a base. So it will be e to the power ln x minus 1 equals to e to the power 3. As you see, we take e as a base. So ln with e, they will cancel, x minus 1 is remaining, and e to the power 3 equals to 20. If you do it by a calculator, you'll get 20. So move this negative 1 to the other side. It will be x equals to 21. That's it. This is how we find the value of x. Another example, we have ln x plus 2 equals to 1. We know that we can take e because we have ln. We take the inverse of ln, which is e. So we have e ln x plus 2 equals to e to the power 1. Just take this note. If we have e, we will put ln in front of the e. If we have ln, we take e as a base. So the ln, this function, will be a power, will be exponent. Then these two will cancel. Let's come back to our example. These two will cancel. X plus 2 is remaining. E to the power 1 equals to 2.7. We know that. Or you can do it by a calculator. Move this 2 to the other side. It will be x equals to 0.7, because 2.7 minus 2 is 0.7. That's it. It's very easy examples. If we move to here, you can simply see that we have ln e. So ln with e will cancel. 1 is remaining. Here we have ln e x minus y. These two will cancel. X minus y is remaining. So these two will cancel. That one is remaining. And e with ln 2 will cancel. 2x is remaining. It's very simple. But in here we cannot immediately cancel them. We move to this 3, e ln x to the power 3. We make this 3 as a power. So these two will cancel. X to the power 3 is remaining. That's it. Thank you for watching.